Welcome to April's Leetcode challenge. Today's problem is furthest building you can reach. You are given an integer array heights representing the heights of buildings, some bricks, and some ladders. So you start your journey from building 0 and you move to the next building by possibly using bricks or ladders. While moving from building I to I plus 1, if the building's height is greater or equal to the next building, you do not need a ladder or bricks. So what that means is if the next building is smaller or equal, you can just jump off and fall down. You don't need any bricks or ladders to climb up. Now, if the buildings is less than the next building's height, then you can either use one ladder. This ladder can climb up the building no matter how tall it is, or you can use bricks. The bricks you'll have to use though is h plus 1 minus h1. So say that building this height is 5 and this one's going to be 10, you have to use 5 bricks. So our decision is to use whether we should use number of bricks or we should use one ladder to travel to the next building. Now we want to return the furthest building, 0 index, the index that you can reach if you use the given ladders and bricks optimally. Okay, so here's a nice little graphic here. You can see that from building 1 or building 0, we have a height of 4, then we can fall. We don't need any bricks or ladders, we can just fall here. Then we can climb using 5 bricks to climb to the third building. As you can see this graphic that just travels. Nice little graphic here with Leetcode. Okay, so great. So they give you a couple hints and assume that the problem is to check whether you can reach the last building, and you'll have to do a set of jumps. What they mean by jumps, I think, is like the climb, and you have to choose whether to use rope or bricks or the ladder or bricks. It's always optimal to use the ladder for the largest jumps. So that makes sense, right? If we have a bunch of jumps that we need to make, and each one being different amounts, we want to use the ladder for the largest heights difference, right? The rest we want to use with bricks. So the smallest ones we want to use with bricks, and that's going to be how we can optimize our use of the ladders and bricks. Now they tell you to iterate on the buildings. This isn't very helpful to me. But initially, I thought this was going to be very simple. All we need to do is find the differences from each building to each building, and the ones where the next building is higher, sort that out and see if we have enough ladders to take care of the largest ones, and then see for the rest of the heights, do we have enough bricks to cover those. But that's not going to work here because we actually don't know. Well, first off, that's not the question. The question isn't can we reach from the beginning to the end. The question is what's the furthest building that we can reach given our ladders and bricks. So with that in mind, that kind of changes the question. Then we have to figure out, well, as we iterate down our journey, what is going to be our optimal use of these ladders and bricks. Right, so let's begin by first initializing n to be the length of heights. And what we're going to do is iterate down our buildings for I in range of n minus 1 because we only care about the differences. And the differences, let's call it h, is going to be equal to the heights of I plus 1 subtracted by heights of I. Now what we're going to do is we already know we have some number of ladders and some number of bricks. As we iterate down this, we're going to use a greedy approach. And what we'll do is have some sort of data structure that stores the difference in difference of heights. Now, in the beginning, we'll just assume that we'll always use ladders. Like if we only have 3 buildings that have some amount of heights, then we'll just use the ladder. If we have 3 ladders, then we don't really care about bricks, right? So we can assume that as soon as we find that we don't have enough ladders to cover any of those differences, what we'll do is have some sort of data structure. What I'm going to use is a heap here, and we'll pop off the minimum height difference. Okay, because for that minimum height difference, we'll use bricks for that. The rest we'll use ladders. And we'll just build this kind of like almost like a sliding window. We'll be popping off the minimum height difference and seeing if we have enough bricks to cover those while we're covering the rest with ladders. And if we do, then we could return, the length of, or the last index number of this buildings But if we can't, as soon as we find that we don't have enough bricks and ladders to cover it, we already know we optimized using our formula, right? So at that point, we'll just return the index that we have. So I'll show you what I mean. The first thing we want to do is check to see if the height difference from the second one to the last one is positive. I mean, if it's less, then we don't care about it because we don't need bricks or ladders. So if h is less or equal to 0, we'll just continue because we don't care. Okay, now what we're going to do is we'll check to see if we have enough ladders or not to cover. So if length of heap, well, first we got to add to our heap, right? We're going to add heap push to our heap, this height. And if our length of heap is greater than ladders, the number of ladders that we have, then we need to pop off the minimum one. So we'll call this min h, heap pop off our heap. And we'll subtract this minimum height from our bricks. Now finally, we want to see, do we have enough bricks still left to continue? Because if our bricks is less than 0, or I should say less or equal to 0, well then we're done. We don't have enough bricks and ladders to cover anymore. So we just return our I at this point. Otherwise, if we're able to fill this entire loop, we'll return n minus 1. So let's see if this works here. So looks like it's working. Let's go ahead and submit that. Okay, so I got the wrong answer. Let's see what I do wrong. So what's going to happen is we use our ladder, then 3, 3, 1 ladder bricks. 3, 3. I actually feel like my answer is right here. Because if we only have 5 bricks, then we'll use our ladder here. Then we'll use 2 bricks, 3 bricks. No, actually, never mind. Maybe it's less like this. Okay, there we go. So that's accepted. So, no, why did that not work? Less or equal to 0. I'm not totally sure, but I guess it's only when we have negative amount of bricks that we need to return the I suppose, since we're at the, because we're at that previous index, you know, we used all our entire amount of bricks. It's only if we have less than that amount that we need to return that I at that point, right? Okay, so that makes sense. All right, so time complexity wise, it's going to be O of n, and we do use O of n minus 1 space because of our heap. And actually thinking about it, it's not going to be n. It's going to be n because of our heap thing. It's going to be n log L, which is going to be the number of ladders we have. It'll be n log L. Okay. All right. I think that's pretty self-explanatory. Not an easy question. I definitely had to look a lot of this up, but hopefully you get the intuition behind it. I think the main thing here is to make sure to use your ladders on the largest heights and make sure to use the bricks on the smallest ones. Okay, thanks for watching my channel. Remember, do not trust me, I know nothing.